Welcome all for today's science lesson. I hope that you are enjoying well at home and waiting for today's science lesson. Okay, let's start today's lesson. Changes in matter part 3. That means the first part of this lesson we discussed in previous sessions. So now I am going to continue that lesson from here. First of all, I would like to mention the competency and competency level that this lesson belongs. This lesson belongs competency 2. Investigate matter, properties of matter and their interactions to enhance the quality of life. And this lesson belongs to competency level 2.4. Uses chemical changes suitably to fulfill necessities in life. Now I am going to continue today's lesson. Reactivity of metals. Metals, you know about that one. In the previous grades also, you learned about the metals. The physical properties of metals, the chemical properties of metals, you learn. If we get the metals that we used in our day-to-day life, we used gold. Sometimes we use iron, zinc, and also we are using some other metals for different purposes. Today we are going to discuss about the metals with their reactivity. Look at this, children. The periodic table. You know about that one. The periodic table includes number of elements. The elements are put into the periodic table according to their different properties. By observing the periodic table, we can get many informations about the element. Here look at this one. The same periodic table. But here I mentioned the elements as metals, metalloids and non-metals. That means the elements we can classify according to their different properties. Look at this one. Most of the elements are metals. If we consider about these metals, they are not reacting in the same manner. They are reacting in different manner. And also they have different properties. That's why we use them for different purposes. Today we are going to discuss about these metals. Look at this one. Lithium, sodium and potassium metals are present. So if we consider about these metals, we are not keeping them exposed into the air. The reason is they are more reactive. When we are keeping them exposed to the air, they can react with the components which are present in the environment. Here we store these metals in liquid paraffin, if not kerosene. And look at this one. Magnesium ribbon. In this first picture, you can see a roll of magnesium. If we get the magnesium, we can keep them exposed into the environment. But what happens is, when we are keeping magnesium exposed into the air, they make magnesium oxide layer around them. And when we use them for certain experiment, we need to remove that magnesium oxide layer around them. Look at the second one. That is clean magnesium strip after removing the magnesium oxide layer. In a way, we can take the other metals. They are keeping exposed into the air because they do not react with the component present in the air. If we get zinc, copper, gold, such metals, they do not react with the air. That's why we can keep them exposed into the air. To find the reactivity of metals, here we are going to discuss about how metals react with air, how metals react with water and how metals react with dilute acid. First of all, I would like to discuss about how metals react with air. To observe that one, so there's a certain thing that I need to show you. Think about sodium metal. So we know sodium stored in liquid paraffin or kerosene. If we take sodium metal out from that bottle and if we heat it by using a burner, what happens? It burns with a yellow color flame. That means sodium reacts with oxygen present in the air and form its oxide. So we can represent it by using that chemical equation. Sodium reacts with oxygen and form sodium oxide. As the same way, we can heat magnesium. When we heat magnesium in air, what happens is magnesium reacts with oxygen and form magnesium oxide. In your previous lesson, you observed how magnesium reacts with oxygen. It gives a bright white flame. Look at this one. That is the equation for reaction between magnesium and oxygen. Magnesium reacts with oxygen and form magnesium oxide. Okay. If we consider about some other metals, think about zinc, iron and copper. They are also keeping exposed into the air. When we heat zinc, iron, copper in air, they do not show any observable reaction. They become dull and sometimes when we heat them a longer period of time, they become its oxide by reacting with oxygen. Look at this example. When zinc heat a longer period of time, it reacts with oxygen and form zinc oxide. Then I am going to discuss about how some other metals react with oxygen. If we consider about silver, platinum, gold, so they do not form their oxide when burned in air. By using these all observations, we can conclude that metals do not react with the oxygen in same manner. That means their reactivity is different. Okay, now I am going to discuss about how metals react with water. If we get the sodium metal, magnesium, zinc, copper, like metals, they react in different manner with water. So if we consider about the water, we can take them in different ways. Sometimes we can consider how metals react with cold water. If not, how metals react with hot water. If not, with steam. Okay, now I am going to show you a video relevant to this part. That means how sodium, lithium and potassium metals react with cold water.
Here I'm working with some lithium metal, very difficult to cut. I've got a piece of sodium here, pretty easy to cut. You notice when I cut through that the fresh sodium is very shiny compared to the rest. Let's zoom in real quick. Let's see if we can really get in there. So this side will reflect a lot of light. The other sides are pretty dull. And you'll see that especially with the potassium here. I'm going to go ahead and give this kind of a half cut. So for the potassium, this is the side that's freshly cut, and you can see the dullness to the other sides compared to that one. So I'm going to go ahead and take those three and I'm going to add them to water, and we can look at the kind of reactivity of those three alkali metals with water. So here I'm going to take the lithium and add that to the water. It's going to generate hydrogen gas and lithium hydroxide. So you're going to see a pink color develop here, and then you're going to see some smoke come off, and that's either lithium metal or that's lithium hydroxide coming off of there. Maybe a little bit of liquid water. But it's not as reactive as, say, sodium, so I'm going to put sodium into the next one. And the sodium is actually probably going to ignite. So you'll see some orange flame perhaps, or some sparks, or some shrapnel. And then the last one, I'm going to go ahead and put my 2 pieces of potassium in that I've cut in half. So this is less potassium than the other 2 in terms of amount. But you'll find that the reactivity is a little bit greater. Now that potassium there was quite reactive there, but the sodium sometimes will allow hydrogen gas to build up. In this case it's not igniting, but we can try adding another piece here. And we can hope that that's going to go ahead and actually send off some shrapnel and some flame. All 3 produce hydrogen gas, all 3 produce hydroxides. There's your alkali metals. Next we're going to go ahead and do the rubidium and cesium.
Okay children, I think you watched the video well. In that video, you observed how lithium, potassium and sodium react with cold water. Look at this picture. This picture explains how sodium react with the water. At that time you can observe the flame. Sometimes the sodium move through the water with hissing sound. And if we consider about lithium, sodium, potassium like higher reactivity metals, they react with cold water and form their hydroxide and hydrogen gas. Here look at this equation. Sodium react with cold water and form sodium hydroxide and hydrogen gas. Now I am going to do a certain experiment relevant to the reaction of metals with cold water, hot water and steam. Okay children, let's start. Look at this. Here as metals, I got copper, magnesium, iron and zinc. Now I am going to check how these metals react with cold water. Here I got 4 test tubes by labeling as magnesium, zinc, iron and copper. Now I am going to add the strip of metal into that test tube. Here I put magnesium, then zinc and iron and here copper. Now I am going to add cold water into each test tubes. Look at this very carefully because you can observe what happens in there. add cold water into that 4 test tube. Look at these test tubes. Can you observe any change occur in there? If we take magnesium, there's no any change occur in it. And if we take zinc, here also there's no observable change. If we get iron, here also there's no observable change. And copper also the same. That means if we consider about that 4 metals, they do not show observable change with cold water. Now I am going to check how these metals react with hot water. For that one also, I have got some test tubes by labeling with magnesium, zinc, iron and copper. Now I am going to add these metals into that 4 test tubes. First I am adding magnesium, then zinc, iron and copper. I am going to add hot water into each test tube. Observe that, children. Here I put different metals and after that I pour hot water into each test tube. If you observe that, look at this one. If you observe it very carefully, you can observe there are small gas bubbles which are evolving near to that magnesium strip. I think it is clear to you. That means magnesium react with hot water, but it do not react with cold water. You can compare with the test tube with cold water. Look at this one, zinc. When we put zinc into hot water, there is no observable change. Look at this one, iron. Here also we can't see any change occur in iron. And the last one, copper. It also do not react with hot water. By using these observations, you learn that the metals, they do not react with in the same manner. Here you observe some metal react with hot water, but some were not. That's why here we are going to observe how these metals react with steam. Under these conditions, we can't do an activity to check how metals react with the steam. That's why I am going to show you something. Look at this one. In this picture, you can see there's a test tube and inside of that one, a ribbon or the magnesium ribbon, and here the burner. When we heat that one, the steam is produced and the magnesium ribbon which is present inside of that one react with steam. As the same manner, we can do the activity to check how the other metals react with the steam. Okay. Now I am going to explain about these experiments that we did. If we consider about magnesium, magnesium does not give any observable change with cold water. But magnesium reacts with hot water and form magnesium hydroxide and hydrogen gas. Look at this equation. Magnesium reacts with hot water and form magnesium hydroxide and hydrogen gas. If we consider about magnesium, it reacts with steam very fast and it forms magnesium oxide and hydrogen gas. Magnesium reacts with steam and form magnesium oxide and hydrogen. If we consider about zinc, it do not react with cold water and also with hot water. But if we can heat zinc with steam, at that time it reacts with the steam. Look at this picture. This picture explains how zinc heat with steam. Okay. Then aluminium, zinc, they do not react with cold water or hot water. They form their oxide and hydrogen gas when heating with steam. Look at this equation. When zinc reacts with steam, they form zinc oxide and hydrogen gas. Now think about iron. If we get iron, it do not react with cold water and also with hot water. But iron forms its oxide and hydrogen gas when heating with steam. Here, look at the equation. Iron reacts with steam and form its oxide and hydrogen gas. Okay. By using these reactions, we can identify how metals react with water. Metals do not react in the same manner with water because their reactivity is different. Now let's check how metals react with dilute acid. Okay children, let's observe how metals react with dilute acid. You know, in our labs we can use different acids: hydrochloric acid, nitric acid, sulfuric acid. But in here I used hydrochloric acid, a colorless solution. Then here I got 4 test tubes by labeling as magnesium, zinc, iron and copper. Now I am going to add these metals into that 4 test tube. First, magnesium, then zinc, after that iron, finally copper. Now I am going to add hydrochloric acid into that 4 test tubes containing metals. I am starting from copper. Children, you need to observe it. You can observe there are some gas bubbles evolve from that metal strips. Here you observe that how the metals react with that dilute acid. They react with the acid and releasing hydrogen gas. That's why the gas bubbles are evolving. But if we observe the reaction of the metals with that acid, they do not occur in same manner. They react with different speed. That means the metals, they react with acid with different speed because of their reactivity. Okay, now I am going to explain about the reaction of metals with acid. Okay, look at this. If we consider about magnesium, aluminium, zinc-like metals, they react very fast with dilute acid and form its salt and hydrogen gas. Here, how magnesium react? Magnesium react with hydrochloric acid and form magnesium chloride and hydrogen gas. Aluminium, if we used aluminium react with hydrochloric acid and form aluminium chloride and hydrogen gas. If we use zinc react with hydrochloric acid and form zinc chloride and hydrogen gas. But these metals do not react with same speed. If we consider about iron, it reacts with dilute acid, but it occurs very slowly and form its salt and hydrogen gas. Iron react with hydrochloric acid and form iron chloride and hydrogen gas. If we consider about copper, they do not show any observable change with dilute acid. Okay children, now I think you got the idea about how metals react with dilute acid. They are not react with same manner with dilute acid because their reactivity is different. Okay, now I am going to discuss about another activity relevant to the chemical changes. Here, the reaction of metals with solution of other metallic salt. Look at this picture. In this picture, you can observe few iron nails. Here, copper sulfate solution. It is blue in color. When we add iron nail into copper sulfate, what happens? It represents in the picture given here. What happens is when we add iron into copper sulfate, iron reacts with copper sulfate and reduces the color of copper sulfate. Here what happens is the iron replaces the copper present in the copper sulfate solution. That means the metals can displace another metal from its salt. Look at this picture. Here, copper strip and zinc sulfate solution. If we are adding copper into zinc sulfate solution, what happens? Look at this picture. Here, the copper strip added to the test tube with zinc sulfate. But there is no observable change. That means copper do not react with zinc sulfate. As the same manner, some metals do not react with the salt of other metals. The reason is their reactivity. So, I am going to explain about that one. The metals with more reactive can displace another metal from an aqueous solution of it. That's why when we are adding zinc into copper sulfate, they form zinc sulfate and copper. Here is more reactive than copper. That's why it reacts with copper sulfate. Look at this one. If we consider about copper and zinc sulfate, if we add copper into zinc sulfate, there's no change occur. The reason is copper is less reactive than zinc. That's why it do not react. Okay children, now you observe how metals react with water, air and dilute acid. So by using the observations, you can conclude that the reactivity of metals are not same. Think about the metals that we used for the experiment. We use sodium, magnesium, zinc, iron and copper. If we arrange these metals according to their reactivity in the descending order, look at this one. Sodium is higher reactive metal. That's why it reacts with cold water. Think about copper. It is very lesser reactive metal. That's why we didn't get any observable change with copper with water or acid. So likewise, we can arrange the metals in an order of their reactivity. As the same manner, the scientists did some experiments relevant to the metals and they arrange the metals in an order and create a series. So that series we consider as the activity series. What is activity series? The series obtained by arrangement of metals in the descending order of their reactivity. Look at this one. Here there are metals. They are arranged in the descending order of their reactivity and obtain the activity series. At the top of the activity series, more reactive metals are present. At the bottom of the activity series, less reactive metals are present. And if we go downwards, the reactivity decreases. Let's see what are the metals present in the activity series. Potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen. Hydrogen is not a metal, it is a non-metal, but comparing the reactivity, we used it to the activity series. Then copper, mercury, silver and gold. So here the symbols of the metals are given. Children, you need to remember these metals in an order. So how do you remember those things? So it is very easy. I am going to show you a simple way of remember the activity series. Here, look at this one. By using that silly sentence, you can memorize the activity series. Please stop calling me a zebra. Instead, try learning how copper saves gold. The thing you need to do is remember that silly sentence. By using that silly sentence, you can memorize the activity series. Look at the first letter of that one. Please, P represent potassium. Stop, S represent sodium. So likewise, the first letter of that words represent the metals in the activity series. That's why it is easy for you to memorize the activity series. Okay. Now I am going to discuss about the uses of the activity series. Then here we are discussing about the uses of the activity series. The activity series is useful to identify the precautions to be taken when storing metals. That means if we consider about some higher reactivity metals, we discussed earlier how they are storing. If we get sodium, potassium, calcium like metals, we store them in liquid such as kerosene and liquid paraffin because of their higher reactivity. Okay, here you observe the picture where the lithium, sodium and potassium store inside of the bottles with kerosene or paraffin wax. Let's see another use of the activity series. Activity series is useful to find the method that prevent corrosion of metals. When we keep metals exposed into the air, what happens is they react with the component present in the air and they get corroded. To prevent that one, we can use some other higher reactivity metals. When we keep contact with higher reactivity metal with the lesser reactivity metals, we can protect the lesser reactivity metal from corrosion. Look at this example. Keeping iron contact with metal like zinc and magnesium that are more reactive metals than iron to prevent rusting of iron. Okay. Now I am going to explain about another use of the activity series. Activity series help to select metals to make electrochemical cells. You know about the electrochemical cell. When we are making the electrochemical cells, we need to select some electrode for it. When we are selecting the electrode, we use the activity series. The higher reactivity metal used as the anode or the negative terminal and lesser reactive metal we used as the cathode or positive terminal. Look at this picture, magnesium and copper. Magnesium is higher reactivity metal, that's why it used as the anode or negative terminal. Copper is lesser reactivity metal, that's why it used as the cathode or positive terminal. So likewise, we can identify the electrode used in electrochemical cells by using the order of the metals in the activity series. Another use of the activity series. Activity series can be used to decide on the method suitable for extracting metals. What is meant by extracting metals? The metals mainly present in the nature as their compound because of their reactivity. So we can find the metallic compound as the ores in different places on the earth. If we get the metallic ore, we can purify that one by separating some sand or the rocks which are present in it. After that, we can obtain the metal compound. If we have the metal compound, we can obtain the metal by using different methods. Obtaining metal from its compound by using different method we consider as extraction of metals. So by using the activity series, we can find the way of extracting different type of metals. Look at this, children. Extraction method. If we consider about higher reactivity metals, potassium, sodium, calcium, magnesium, aluminium. Such metals can be extracted by electrolysis of their fused chloride. And if we consider about middle reactivity metals, zinc, iron, tin, lead, copper, like metals we can extract by reducing their compounds by other elements or compound. If we consider about silver, gold and platinum metals, they are present in the nature as native metals. That's why we can extract these metals by simple physical method. So likewise, we can identify the extracting method of metals by using the order of metals in the reactivity series. Now I am going to discuss about the extraction of iron. So we are not going to discuss about all the method of extracting the metals, but here the extraction of iron. So we know iron placed in the middle of the activity series, and also if we need to extract iron, first we need to obtain iron ore. If we consider about the iron ore, the main component present in it is hematite. Sometimes the little amount of magnetite can be present with the iron ore, but here we consider about hematite only. To extract the iron, so we need to get some raw materials. So here I am going to explain about the raw materials that we need to use for extracting iron. Iron ore, the main component in it is hematite. Limestone, that means calcium carbonate. Then coke, that means carbon. So we take these raw materials in a certain ratio. After that, we used a special furnace for extracting the iron. So we consider it as blast furnace. If we consider about the blast furnace, it is about 60 meter in height. And also the temperature range within the blast furnace is about 1000 degrees Celsius to 1900 degrees Celsius. Look at this picture. This is a picture of an interior view of a blast furnace. At the top of the blast furnace, there is opening to insert the raw materials. And at the bottom of the blast furnace, there is opening to insert the hot air. Due to that hot air that we send from the bottom, the temperature inside of the blast furnace is created. And there is a fire clay brick wall. The reason is there is higher temperature inside of the blast furnace. To withstand in that higher temperature, the fire brick wall is present. Then if we consider about the bottom of the furnace, there are two openings to remove the product from that furnace. Now I am going to explain about the procedure that we use to get iron from the hematite. The raw materials are inserted to the blast furnace from the top while the hot air is blown from the bottom. The heating caused by hot air brings about several changes inside of the furnace. Let's see what are the reactions occur inside of the blast furnace. First, the coke burns in air forming carbon dioxide. Then the carbon dioxide gas reacts with coke and form carbon monoxide gas. Then the carbon monoxide reduces the iron ore into liquid iron. If we consider about that three reactions, they are not occur in an order. These reactions may occur in different places of the blast furnace and produce iron. If we consider about the iron ore, not only hematite present in there are some impurities present with hematite like silica or alumina. So we need to remove that impurities. For that we use calcium carbonate. Because of the heat present inside of the furnace, the calcium carbonate decomposed and form calcium oxide and carbon dioxide. That calcium oxide react with the impurities and form calcium silicate and calcium aluminate. Look at this one. Calcium oxide react with silica and form calcium silicate. Calcium oxide react with alumina and form calcium aluminate. The mixture of calcium silicate and calcium aluminate we consider as slag. If we consider about slag, it floats on the molten iron. And molten iron and liquid slag we separate from the bottom of the blast furnace. Okay, now I am going to summarize the extraction of iron by using the blast furnace. Look at this picture. Here at the top of the blast furnace, we insert the raw materials, iron ore, coke and limestone. And at the bottom of that one, we are inserting the hot air. So these are the reactions occur inside of the blast furnace. And finally, the molten iron flows to the bottom and slag floats on the iron. Then we separate iron and slag from the blast furnace. That is the way we extract iron from its compound using the blast furnace. Now I am going to explain how gold metal extracted. So you know, gold present in the nature as native metal because their reactivity is very low. That's why gold present in the bottom of the activity series. Gold does not react with any active component present in the atmosphere in normal conditions. That's why gold occurs as native metal in the nature. Simple physical method can be used to extract gold. Look at this one. The gold ore is powdered finely and mixed into drained water. At that time, the gold settles down on the bottom of that container. So that is easy way to obtaining gold. Look at this picture. It shows how gold obtained by using this method. Okay children, now we come to the end of today's lesson. So I am going to summarize the things that we learned today. So we discussed about the reactivity of metals. How metals react with water, air, dilute acids. Then we discussed about the activity series. So we build up the activity series by comparing the reactivity of the metals. Then we discussed about the uses of the activity series. Finally, we discuss about the extraction method of iron and gold. I think it is clear to you. Okay, my children, if you missed these lessons, so you can watch them again by using the YouTube channel. So I hope that you watch them again. Now I am going to end up today's part. Goodbye.